CLT Wall Fire Calculator allows you to simply design the CLT wall subject to fire with appropriate design methods across the world. With a connection to the supply chain, this calculator enables the rapid and safe design of CLT walls, ensuring the highest and most accurate fire design at code compliance. Firstly, input your supplier. As you change the wall layups, you can see below how dynamically the layers and char model are changing. You can select different suppliers from Australia and Europe. Then, you can begin inserting your variable. Input the design method. This typically depends on the user location. If you're based in Australia and using Australian supplier, you have the local loading code and local design methods, or if you're based in Europe, you can choose the Euro codes. Next, input the loading combinations. We have different load combinations, or you can input your own manually. Also, you can input forces directly from a different analysis package. Now, input your analytical method. We have different methods from around the world: Shear Analogy, Gamma, and Extended Gamma method. You can see all the in-depth information and reference documents for each method on the drop-downs menu. We'll continue with the Extended Gamma method. Next, select Yes/No to consider the cross layer. You can use the Education drop-down for more information. Then, select the framing type. Platform, typically where the height of CLT walls is equal to the height of a story. Or select balloon, where CLT walls are erected along the entire height of the building, and the floor panels are suspended to the walls of each story. Next, input the fire data. Insert the FRL. If you're unsure of anything, you can use the Education or drop-down to learn more. We have information what the input is, also information for the fire tests, and some video education on the compliance pathway. Next, input the glue line performance. Some glues may cause the char to fall off, which means before the fire reaches the glue line, the layer falls prematurely. So this is reflected in the glue line maintenance drop-down here, where you have an increased char rate at the beginning of the layer. Next, put the side exposed. For CLT walls, there could be situations with the right face exposed, the left face exposed, or both. Every change is dynamically applied below. Walls could be unprotected as bare CLT and more protected with plasterboard. Now, input your encapsulation. The first period 0 represents the +4 protection where the plasterboard hasn't begun. Then you have the next period where the plasterboard is still there, but the pyrolysis reaction has begun. Still, the user has the flexibility to choose the length of both periods in minute. We'll continue with the left face exposed only. Then, you can input the char rates. You can see there are different char rates, which are going to vary on suppliers, so you can get the information directly from the supplier chain. Also, there are tables from Eurocode for reference. For the next input, you have the loading data. Use the educational drop-down for some more information. There is also an input for eccentricity and wind loads. Referring to the drop-down from the education, you can see here more information for Eurocode factors. When completed, you can review the calculations. Click Save and Minimize to begin. Calculations with the CLT toolbox are never a black box, and you can understand what the software is calculating in each step. We always have reference for transparency for you to follow and check out further. Also, it's possible to temporarily turn off some of the verifications tab as you prefer. Also, there is an option to hit Solve to see what the most efficient panel layout is from that supplier. So you can hit Save and print to the PDF. So now we have easily and detailed design reports ready to be submitted for review and calculation documentation.